ලින්ක් එක දෙන්න ඉස්සෙල්ලා ඔකට යන්න ඉස්සෙල්ලා අපි ලින්ක් එක දීලා ලින්ක් එක groups වල දාලා remind එක දාලා තමයි යන්න ඕනේ. ඔයා මේ ලින්ක් එක දෙන්න දැන්. Good morning, everyone. So we are ready to start the first cover up for vectors, but it is a kind of a comprehensive plan. So we are going to start these vectors. This is a 1 month of work, completely covering up the theory first, and we are jumping to past paper discussions, whoever missed the lesson for vectors and scalars. To start this program, so we'll have a quick chat about it. What is a vector? Think from your side, start thinking. What is your answer for vectors? Vectors. Why do we have like two concepts called vectors and scalars. So when we go to a boat, right? So we'll have a small idea about it first. We know that we started from physical quantities. We start about the physical quantities. We mainly divided the physical quantities into two parts. One, we call them fundamental physical quantities. So I usually call FPQ, fundamental physical quantities. Always my pattern of work, I usually tell people to have abbreviations to remember that easy. So the derived physical quantities, so DPQs. So then we divide the derived physical quantities into parts, you know. So we were doing this all this time, but other than this particular division, these physical quantities can be again divided into PQs, can be again divided into two based on another feature. So you all know that the dichotomous key is based on something. Now, fundamentals and derived are based on one sort of a quality. What was the quality? We were talking about one important quality. What was that quality? So we checked only the availability of fundamental units. Based on the unit definitions, we divided physical quantities into two parts, fundamentals and derived. Now here, this dichotomous is for something else, right? So what is it? Scalars and vectors, right? Scalars and vectors. Now keep this in your mind. Now what feature they are looking for? What feature they are looking for? What feature they are looking for? What do you think? They are looking for the availability of the direction. And we leave it that simple at the beginning, but remember, it is not just the direction. So we need to come across a clear picture about the availability of direction. This direction must be a linear direction. What is a linear direction? What's a linear direction? Linear direction is the direction which can be represented by a straight line with an arrowhead. Straight line with an arrowhead. So there's a joke, vector asked from a scalar. Or sometimes some meme says force asked from pressure. Are you straight? Right? So pressure is a bit complicated. Pressure's answer was, no, it's a bit complicated. We'll come to that one in a couple of minutes. Right? So why this direction should be a straight line direction? A straight direction can be illustrated using an arrowhead with a straight line with an arrowhead. Why? Because sometimes we may have some complicated directions like the direction of pressure. I mean, honestly speaking, vectors and scalars are not taken that way. So the definition of the directions comes with the dot product and cross product, which is in mathematics, right? In mathematics, you are learning vectors into a deeper extent. Unfortunately, physics, we are sticking to the basics because we do not teach you the cross product and dot product. So let's not talk about it for now, but we'll do another session on that for people to understand what exactly what's the reason we take the vectors and scalars division. So sometimes people may feel like the pressure is a vector because it acts to a direction. So we'll come to that point. With these small explanations of the basics of the vectors and scalar after the points. So here, scalars are quantities with no straight line direction. With no straight line direction. So the vectors are quantities with a straight line direction plus the magnitude. Magnitude is a must for all physical quantities, right? That's why I said physical quantities. So let's go back to our work, right? So let's go to this part. Okay. A study of motion. Okay, we go for this, the fundamentals of it. Vectors. So vectors are physical quantities with a magnitude and well-defined linear direction. Magnitude and a well-defined linear direction. So why I call this well-defined, right? Why I call this well-defined? Well-defined direction is a direction which can be properly explained using a straight line with an arrowhead. Now, sir, for an example, we'll try to make this clear with you. Now, we know that we have heard that some, directions called clockwise and anti-clockwise. Clockwise, anti-clockwise. So clockwise and anti-clockwise directions are not well defined. Think one simple point, clockwise. What direction I'm rotating my hand? Clockwise. What the direction you see? For me it is clockwise. For you it is. And I turn the same direction, I keep on turning. Now what is this direction for you? For you it is clockwise again. Right? So there is a confusion from the point of view. So because they are not well defined, so then we have to define a straight line direction, linear direction. So then only we can consider that as a vector. If you want to consider a physical quantity, you have to define. Sometimes you can obviously see the direction, or sometimes you can define a direction. But direction must be linear. So that is what we call as well-defined direction. So the displacement, velocity, acceleration, they are properly defined vectors. Force, properly defined vectors. Momentum, properly defined vectors. Now, since we have done a little bit of linear motion, let me tell you the direction of displacement. Direction of displacement. So the direction of displacement is from the starting point to the end point. From the starting point to the end point. So this is the starting point. And this is the end point. So you understand that is the direction. So, I mean, my line is not a straight line, but it's a direction. So velocity is, again, the object moving to this side. So start direction of displacement. Direction of displacement affect direction of velocity. Acceleration will learn a little bit complicated manner, but there is a direction to the increase of the velocity, that is the direction. Force, since from, I mean, you have learned O levels, F equals ma, the direction of the force is direction of acceleration. So acceleration direction affect force. Momentum is defined as mass into velocity. So the direction of velocity comes to direction of momentum. So meanwhile, I added little bit of, complicated ones also here, right? I have added some complicated ones to give you like a little bit of advanced level feeling. Otherwise, you may be thinking, okay, it's very easy because it's O level stuff we are learning, right? The displacement, velocity, acceleration and all are from what? O levels. Even the momentum you have learned in O levels, but electric field intensity, we are learning in unit number 6. There are little bit of few quantities there. They give us what? The vectors, new vectors to deal with in the future. Magnetic flux density. Magnetic flux density we are learning in unit number 7. So on. And let me tell you, like even the current in the higher subject matters, like in the university level, you consider sometimes current as a vector. So that is something very serious you need to understand. So that is based on the definitions you make. You have to define proper linear direction to understand it. So that's how it is. So to analyze, to add, to deal with it, to learn comprehensively, sometimes we need to consider the direction of the physical quantity, right? Okay, so scalars, very obvious now. Quantities with no linear direction, so but with a magnitude, of course. So there are like quantities I like to call mass, time, density, area, volume, are like, quantities with no direction at all. But sometimes pressure, angle, speed, you may feel that, they have directions. Yes, let's talk about them. So sometimes you may have like a feeling pressure is a quantity with a direction. Yes, pressure shows or express directions, but you cannot express the pressure direction using a straight line with an arrowhead, no linear expression for that. So for an example from your childhood, you may have seen that, there is a container with holes around it. So these holes ejecting water out. So when the water are ejecting water out, so we all know that. It's simple. So it comes to all directions, yeah? All directions, right? So you understand that is for all directions here. It comes out here. It is coming out to every side. So we can't say which side it is acting properly. And not only that, even the angles. Angles, I like to talk about these angles. So sometimes you may have an idea that, say angle. I measure the angle from a direction. Say you want to measure the angle. So you measure the angle clockwise. You measure the angle anti-clockwise. Sometimes you may have like a feeling, but you can see that's clockwise angle, anti-clockwise angle, but they're not vectors. And speed also, like, so sometimes the speed in concern, when you look at the speed idea, we may feel that the speed is also a vector. Actually, yes, because when you consider the direction of the speed, so we consider, we label, we rename it as velocity. So that's easy to understand. So when you consider the direction and the magnitude both together, that is what? That is clearly velocity. So if you ignore the direction completely, so that can be considered as speed. Sometimes we consider the linear motion, yes, it's only about velocity, not about speed at all. But when you consider about like circular motion and all, so when you consider at a point with the direction of the speed, so that is tangential velocity, something like that. So yeah, so we are learning these individual quantities separately. Till that, we stick to our basics. We are learning vectors and scalars only. So yeah, so how do you geometrically representing vectors? We represent using a straight line with an arrowhead, as I said that from the beginning, right? So let me explain this idea as simple terms. Now here you can see a straight line to a length. You have drawn it into a length onto a scale. Say you need to represent force. You need to represent force of 10 Newton. Can you draw 10 Newton on a piece of paper? Can you draw 10 Newton on a piece of paper? Can you draw 10 Newton force? No, you can't. What do? You develop a scale. Okay, 1 Newton equals 1 centimeter. 1 Newton equals 1 centimeter. So we take 1 Newton, 1 centimeter. So you draw 10 centimeter line and label it as what? 10 centimeter line and label it as, now for example, this one, 10 Newton. So we can label 10, but this length should be what? 10 centimeters. We should label this as 10 centimeters. So we label it as 10. But the value is 10 Newton. What's our scale? 1 Newton is to 1 centimeter. Hope you understand the idea, right? So, and notation as well as the notation. What is this notation about? What is this notation about? Notation. What's the difference between geometrical representation and notation? Notation is the name. Right? So the notation is the name. Geometrical representation is the appearance. So let me explain with a small example. Let me explain with a small example. For an example, now we have like, friends with the common name. Very common popular names like, now even Sanjeewa is a very common name. When I was schooling, there are a couple of Sanjeevas and slight, variations of the names, including like around at least 10. Sanjeeva, Sanjaya, Sanjeev, Sanjay, like that, So when we have variety like that, we have to put some adjectives, and especially our Muslim friends. So, we have like friends with the same name, Imran, Muhammad, Ahmad. So we have a lot of people, but slightly different spellings. So what do? How do you distinguish them? Now they have a name. Name is the notation. Name is the notation. But geometrical representation, we had like good names. I can't tell my nickname for that in public, right? So we call that the tall one, the short one, the fat one, the dark one, the long hair one, short hair one, the fair one. Huh? Not body shaming, not discrimination, but as kids we usually do, isn't it? And as teenagers we always do, we name them with their physical appearance. Sometimes bugging, sometimes, for fun, yes. I also had a very name because I was so skinny those days. Very, very popular name. Right? In university I also had like a similar type of a popular name because I was so skinny. Right? So you can go to my social media sometimes when you scroll down, you can find like photos, you can't even recognize me. So anyway, like now that's a geometrical representation. That is a geometrical representation. Here we are showing the appearance, straight line with an arrowhead. So that is a geometrical representation. Notation is like AB, okay. Say notation AB. So here you can see, A is the starting point, B is the end point. So we mark AB and row the arrowhead from A to B. AB, this read as vector AB, not AB, arrowhead, A to B, arrowhead, AB below arrow. No, we read it, right? Vector AB. So when we put the modular sign, what is the modular sign mean? The magnitude only, like it's 5 Newton, but we don't consider about the direction, like 5 meters per second, like velocity speed idea. 5 meters per second speed, we don't care about which direction it goes. So we can say this is not very popular, but you can say BA. It's not very nice to say because we read always from left to right. Yes. Okay, let's do a small activity. Masses of 5 students in a Lee physics class are given below. So these are the numbers. So can you find the total mass of the group? Can you find the total mass of this group? Can you find the total mass of this group? Yes. Just do it now. big difficult one. It's not a very difficult question. Yes, I know it's 317. I hope you all got the 317 right. Okay, so that's not a big deal for us. Yes, right. I give you another simple question. Simpler than that. And then you can comment in the YouTube as well, asking the questions. You can keep commenting and asking the questions, so that will help us to check whether you are understanding this, or you can use the WhatsApp group. Both available, so you can ask questions. Okay, let's do another one. Right. Kumutu has sent a lot of answers. Very good, Kumutu. Well done. And yes, we can see that. Yeah, so this is the popular answer, very popular answer. But that is with an assumption, right? We thought they are acting to the same direction, but nowhere in this question says like so. So how do you know whether they are acting to the same direction or not? Right? So yeah, this is one possible answer. Possible answer. One possible answer. So it can be like this, can be like that. So that's why Kumutu has given us some, clarity about it with a little bit of different numbers, lot of numbers. Yeah, good, well done. So why is that? Why this complication is? So why this complication is? This complication is because of one small reason. What's the reason? Earlier, the masses can be added easily because they were scalars. But here, vectors force is a vector and we cannot add vectors without considering their direction. Simple as that. And I like you adding this into your small notes because to give you the impression, before you add or subtract something, the first thing should come to your mind. Very first thing come to mind should be what? Whether they are vectors or scalars. If they are scalars, just add them. If they are vectors. So we're going to learn how to add them in few minutes. Please add this into the note. And we can make it a little bit fast. And what about this situation? Can you find the resultant of this? And please draw and write this and leave it. Draw and write this and leave it with a question mark, because in the very next slide we are going to learn this. on mute kain kar liya camera ke liye is it muted or on? So let's try to figure out how do we add these vectors with inclined directions. How do we add these vectors with inclined direction? So that we have to learn the concepts called addition and subtraction of vectors. Addition and subtraction of vectors. You can't just subtract. You can't just subtract vectors, right? You can add vectors using vector addition theories. So let's take this one by one. Why do we need a separate vector addition theories? Why do we need separate vector addition theories to add vectors? Because scalars, we just consider the magnitudes and add them. Now in this case, what do? We consider vector direction and add them by adding the directions, by adding the magnitudes. That's kind of a, a method we use. So there are a couple of methods in our syllabus. Triangular theory, yes, triangular theory of vector addition, and parallelogram theory of vector addition, polygon theory of vector addition, and resolving vector method. Voice on karanna. So we'll take the parallelogram theory of vectors first. We'll take the parallelogram theory of vectors first. So how do you take the parallelogram theory of vectors? What exactly mean by that? It's a kind of complicated statement, but we are not interested about statements, We are not interested about statements much. We go with when two vectors, okay, the very first restriction came to the discussion, two vectors. So we only can deal with two vectors represented by two adjacent sides of a triangle. So we have a triangle. So we have two vectors, 1, 2, we have two vectors, 1, 2. One after the other. That is kind of, trying to imply something. So this is not how we draw it. One after the other. We draw a B vector, and after this we draw BC vector. One after the other. One after that. So we are going in a pattern, right? Okay. So here it is, like we have two vectors P, Q, but this is not the expectation. This is not the expectation. We draw a vector AB. We draw this vector AB. Right? We draw this vector AB. We draw this vector AB. And first of all, AB drawn. And then we draw vector PQ. And now we connect the starting point to the end point. We connect the starting point to the end point. Starting point to the end point. Right? So we repeat the idea. There is a vector Vector goes to this side, okay, and that is called as xy, and draw off one after the other. Very good. So one after the other, and connect the starting point to the end point, and this is known as the resultant. That is the addition of P plus Q. Right? So that is what you call as triangular theory. Simple. Triangular theory, we have two vectors. We represent both vectors one after the other. Draw the first one, starting point to the end point. Start the second vector from the end point of the first vector. Draw to the same angle. And then what do? We connect the starting point and the end point. And then we get what? The resultant magnitude and direction. So here, when we measure this length, that is the magnitude of the vector, and when we get the direction, that will be the direction of the vector. So simple. That's a triangular theory. And we have a lot of exercise to do, but I not plan to do it in this particular YouTube live because I want to check your work one by one. Because we have to draw some, scale diagrams to get the resultants. So we are going to give the exercise in the WhatsApp group, and we are going to have another session, Zoom session, where you can communicate with me directly, and then you have to send the answers, drawings in the WhatsApp group and check and complete. Okay, so that exercise part is coming later. So yeah, that is the end of the triangular theory. So let's go for the parallelograms law, or parallelogram theory, or parallelogram law. So we have same two vectors, AB and AD, AB and AD, same two vectors. So we are going to represent this in adjacent sides of a parallelogram. So interestingly, like you can see, so since this is a parallelogram, so these two sides are equal, right? So when this is Q, this is also Q, and this is theta, so we know that this will be theta, right? So while connecting this, so we connect the starting point, right, this one, the diagonal. So we take the diagonal, and when you draw the diagonal, the magnitude or the length of the diagonal will give us the magnitude, and the direction of the diagonal will give us what? Direction of the diagonal will give us the direction of the resultant. But isn't it the same thing what we did in the triangular theory? Yes, of course, the same thing, because if you ignore this part, you can see the triangular theory. So then why are we having two theories? The thing is, we are going to develop this triangular theory to the next level, to develop a formula. That formula will help you, what? To get the answer. Now, in the previous case of the triangular theory, we went with the geometrical construction. So you all understand that geometrical construction is a mess, like when it comes to very high accuracy. Why? Because say for an example, it's a 5 Newton and 6 Newton, it will be fine. But about like 5.72 Newton to be added to 6.91 Newton. So it won't be an easy task, because say angle between them is like 30 degrees and 14 minutes. So finding a proper scale to do that will not be that easy. So here in this case, what is our plan? We are not going to go for geometrical construction. What we are trying to do? We are trying to gather a technique, develop an equation. That equation will help us to find the value without doing the geometrical construction. So that's why we try to develop here. Keep eye on it. Right? So we extend this line AB to this side and draw a perpendicular from C, and I like to call it as E. Now we have two right-angular triangles. Can you see I have two right-angular triangles? One is a very small one. So that is one right-angular triangle. And there is another big one. So hope you can see that the big one here. So that is another right-angular triangle. So I take the small one first, ABC. ABC, yeah, ABC. And when I take this ABC, I'm only considering about sine, cos, tan, so I like to write sine theta first. So let me write sine theta. Sine theta is opposite side CE. This is called the opposite side, right? And this is the hypotenuse. So opposite over hypotenuse, this is the opposite side hypotenuse. Right? So we get like opposite hypotenuse is Q. We can see that it's Q, right? So then you do the cross multiplication, and that is CE. CE equals what? Q sine theta. So in simple terms, this is Q sine theta. So this is. So we write cos theta. Cos theta is adjacent sides over hypotenuse. So this is the adjacent side and this is the hypotenuse. So hypotenuse is Q again, so we can do the cross multiplication and we can say this BE side is what? This BE side is Q cos theta. So Q cos theta to be taken here. So now I'm done with the small triangle. Now I go to the big triangle. Anyone who want any clarification about this math part, please ask, right? Please ask. Hope you all understand this math part. Right. If there are no questions, right? If there are no questions, we can go to the next mathematical part, right? So what we do, we take the big triangle now. We take the big triangle, right? Now this is our big triangle, right? So this is the triangle we are dealing with now. So yes, Pythagoras theorem. So hypotenuse AC squared plus CE squared plus AE equals 0, right? So AC is R, right? AB is the part of AE plus QE, add them together and go there to build this part, and CE is this EC. Right? Now, how do you expand this one? O-level explanations, x plus y squared equals what? X squared plus y squared, right, plus what? X into y into 2, right? So yes. So that is how you expand it. Yes, okay. P squared Q squared cos squared theta, and multiply these two together and multiply by 2. Done. And from A-level maths, you can understand there is some additional calculation we can do. We can take Q squared out. Q squared out. When you take the Q squared out, this is something very popular in A-level maths. That is called 1. So people who are not doing combined maths, so they may not know that. So I will prove it for you in a while. So this is taken from advanced level mathematics. So people who do bio, just wait until I support you to understand that one at the end of the process. So you replace 1 here. Now we have a good expression. What is it? R squared equals P squared plus Q squared 2PQ cos theta, and using this formula we can find the resultant easily here. You can find the resultant easily. Now earlier we were doing the construction work, geometrical construction work. Now what do? We use a formula to understand this, right? So we use the same triangle one more time and write tan alpha. Why? Because we want to find alpha here. Tan alpha is CE over AB, CE over AB, right? CE over AB, sorry, CE over AE, AB plus BE. CE is Q sine theta. So you can add them and add here, right? So we have the formula now. Tan alpha equals Q sine theta over P plus Q cos theta. Again, you don't have to measure this using a protractor. You can use the formula and find the alpha value using maths. And so we have 2 equations, and slowly go through it and ask any doubts you want to clarify. I'll explain it again. You can drop the question in the chat. Okay, so let's take the other parts again. Now we are done with two theories. Okay. Now again, I'll remind you. We have four theories to do. Number one, what? Number one, triangular theory. Number two, parallelogram law. Number three, polygon and resolving vectors. So we are learning this completely. And then what do? We try to do the past papers. That's interesting. Okay. So, but I don't like to skip these, the bio students. I like to teach you that the mathematics a little bit, revind you the maths part and prove some, the equations we use from advanced level. Yes. Right. So we know that sine theta from the equation. We know the sine theta from the equation. Sine means, okay, opposite over hypotenuse, AC over AB. So sine squared is we square this and we square this, we square this, and cos theta is adjacent into hypotenuse, right? So we square this again, so we square this, square this, square this, and what I do, I add them. Sine squared, cos squared, and this component comes here, this component comes here. So now we can see a common denominator. So BC squared. So AC squared, AB squared. But what is this AC squared plus AB squared? So that is the Pythagoras. AC and AB, those are the adjacents and opposites. When you add them together, you get what? BC, that is the hypotenuse. So yes. So then here AC squared plus BC squared is what? BC squared. So you cancel this off. You get that A-level mathematical formula. A-level mathematical formula, sine squared plus cos squared equals 1. Sine squared plus cos squared equals 1. Okay. So this is interesting. So that is something you can use even in the future for any other topic, because that is a standard formula in pure mathematics, trigonometry more precisely. It's an extra work, okay? Now, what is my plan? We try to develop some useful derivatives. We deduce some equations from the main equation. For special cases, which is more popular in exams, there are several. Now, even we have written r squared equals p squared plus 2pq cos theta, right? So that is not coming all the time. There are some popular formulae we use always in A-levels. For an example, this scenario. Let's see this. Please copy down this. When theta equals 0, that is a popular one. So we put cos theta as 1. So when you substitute cos theta as 1 here, you get a formula which is very popular among you all from O-levels, p plus q whole squared, the complete square, p plus q complete square. So I can take the square root of them and get p plus q. What does this mean? What does this mean? When we have two vectors, A, B, and I'm using a different color to give you the idea, and say PQ, and when they do not acting with an angle because they are acting to the same direction, so you don't have to go for this big formula. What you can do? you can easily add the two vectors when they're acting to the same direction. That's what you did at the very beginning as a mistake. When we have 15 and 10 and 5 Newton together, so we assume that they're acting to the same direction and we added 15 plus 10 plus 5 and got 45. Sorry, I can't remember the numbers. 15 plus 10, 25 plus something, right? Yeah, 20, 15 and 5. 20, 15 and 5. So when we add those numbers, we got these numbers together, added based on the concept in our brain. Our brain like to believe they act to the same direction. So we add them together because of this. So when two vectors are acting to the same direction, so we can easily understand what? We can easily understand they can be added together, resultant. Not only that, so we can get the direction also very easily. We can get the direction also very easily because sine 0 is 0, cos 0 is 1. So q into 0 is 0 and q into 1 is q. So what we get is 0. So alpha is what? Alpha is also 0. So in simple terms, when two vectors acting to the same direction, their magnitude of the resultant is p plus q and the direction is absolutely the same direction of the two vectors. That is why alpha is 0. So no angle between r and p, that means r also acting to the direction of p as well as for the direction of q, because p, q directions are the same. So please copy this down before we go to the next part. Right. So 90° cos 90 is 0. So again, bio students, remember you need to learn a little bit of trigonometry here. So what trigonometry you supposed to know? Number one, you need to know the sine, cos, tan values and you know the basic relationship between sine, cos and tan at least. So yes. So one thing, p squared plus q 2pq cos 90 is 0, and then we know that we can get them together, and that is p squared plus q squared. And this is a very useful formula. Always remember, this is a very useful formula, because when two vectors are perpendicular, vertical one, horizontal one, vertical one, horizontal one, when they are perpendicular, the resultant is p squared plus q squared square root. P squared plus q squared plus square root. So then we go to this. Again, as I said, sine 90 is 1, cos 90 is 0. So you're supposed to know them. And then we get another formula, easy formula, tan alpha equals q over p, q over p, right? Yes. Q over p. So now you understand, it's very easy to obtain, it is very easy to obtain what? Alpha now, unlike we do like, you know, q sine theta over p plus q cos theta, the big formula. So we can quickly take these two perpendicular vectors. Here it is q, here it is p. Divide the vertical one by the horizontal one. You get the tan alpha. Then go to the tan inverse. And yesterday in the class, one student asked how to get this tan inverse. What exactly mean by tan inverse and all. So let me tell you this idea very simple. So we'll have more sessions, and we are starting this important program called Physics Bridge. So especially preparing these bio students to learn the basic maths you need, and how to handle the log values, sine values, tan values. So we are going to do it in a way. And meanwhile, we do this for students who are sitting for O levels, then they can understand that part and come to A level physics classes, right? So you copy down this part and finish. Right, okay. We'll go to another one. Theta equals 180. What is 180? Opposite to each other. Two vectors acting opposite to each other. Right? Say for an example, one vector, wait. One vector to this side, the other vector to the opposite side. So A, B, A, C. So now this is a different vector. So this is a starting. So in this case, you can see the angle is 108. So how do you deal with this? How do you deal with this? So yes, cos 180 is -1. And when you put this one here, you can see that the whole square, the complete square part comes, right? So then R equals P minus Q. Similarly, this is also the same direction, interesting, but you need to understand, to get this P minus Q, we need a small additional requirement to be satisfied, that is P must be bigger than Q. P must be bigger than Q. Why? Because otherwise this will be a negative value again, the direction wise it creates a small problem. So always when you subtract, better subtract from smaller one, subtract from the larger one, right? And this one also, this is the third most important concept, or the additional derivation. Right? Okay, so that is again in the end of what? Parallelogram loop. So we are going to go for a short break. Hold on till that. We'll finish the resolving vector and the polygon theory, short 2 lessons, and then we'll go for what? Question discussion, okay? And we go for a short break and we are going to finish it today as I promised. So resolution of vectors, right? Resolution of vectors is actually not defined for finding resultant. It's a different method. That's why we call it resolving vector method. It's not there here, but it is called the resolving vector method. It's a method. It's not a theory, it's not a law, it's a method. We use this method to find the resultant as an intermediate step. Do you understand? Now, triangular theory of vectors, just to find the resultant of vectors, 2 vectors. Parallelogram theory of vectors to find the resultant of 2 vectors. But vector resolving method is not a method introduced to find the resultant of 2 vectors. It is an intermediate method we use at the middle of the process of finding the resultant. So this method is very useful to find the resultant of more than 2 vectors. 2 vectors, you can just use this above theories and get it. What if we have 3? What if we have 4 vectors? What if we have 100 vectors? So how do you do that? This is one method we can use to find the resultant of more than 2 vectors. So I like to teach this in a different format. I get an example, I take an example. To go there, I take this resultant R. Now I want you to answer my question in the chat. Now how many vectors displaying here? How many vectors displaying here? How many vectors displaying here? Only 1 vector, very good. So the answers are nice and clear, yes. Only how many vectors? 1 vector here, that is R. Clear, very good. So now what I do, I like to resolve this into 2, right? What exactly mean by resolving? We try to write this vector P in terms of R and alpha. Usually this R is the vector, only 1 vector. And I divide this into 2 pieces. What are the 2 pieces? Piece 1, 1 and 2. This is piece 2, 1. Right? So what is my strategy? What I try to do here, I try to write sine alpha. Again, you know that opposite, that is CB. CB is same as DA. So that is Q. And over AC, that is R. Right. And then I can cross multiply R and sine and get Q equals R sine alpha. So I subject Q here, Q equals R sine alpha. And similarly what I do, I like to write cos to the direction of the adjacent side. So that is AB over AC. AB is P. AB is P. AC is R. So you put P and R. So we do the cross multiplication and subject P. Now we have two pieces. The interesting thing, we have two pieces. So this is called the horizontal component, and this is called the vertical component. And now tell me how many vectors we see on the diagram. How many vectors we see on the diagram? One vector, two vectors, or three vectors? One vector, two vectors, or three vectors? Yes, very good. It's only one vector. This is the vector, as I said, and there are components, and they are not another two set of vectors in simple terms. Now we have a cake. We have a cake. We cut this cake into two pieces, big two pieces. Now how many cakes we have? Do we have three cakes? One, two, three cakes? No, we don't have three cakes. Do we have two cakes? One, two cakes? No, we don't have two cakes. We have two pieces of a cake which is equal to the cake. Which is equal to the cake. But we don't have the cake as well. Cake is the full whole thing. So that is R. So when we cut this R into two pieces P and Q, we do not have two cakes. We do not definitely have three cakes. We have two pieces P and Q, which is equal to the full cake R. And R is also not there because we have cut this into two pieces. Right? That is what you call the resolving vector method. So you can copy down whatever you want, and then we go to do one example, and then we go to have our breakfast and come back to the work. You are responding very nicely. Now hope you understood that. Right? That is not three vectors there. right? Okay, now this is how it's gonna work. I'm gonna put a question on the board, you to do using the resolving vector method, and while you're attempting the question, you're gonna have your breakfast and the break. So it's not a full break because we don't want to waste the time here to giving a couple of hours because you're staying home. So you know that you're in a very comfortable environment, right? You have your breakfast while studying, or if you are already, if you have had the breakfast, so what you can do, you can just do the question. So this is the question for you. How many vectors there? I'm going to explain this first. Okay, how many vectors there are? 1, 2, 3 vectors. There are not 2 vectors or 1 vector. 1, 2, 3. This is not the resultant vector. If that is there, we don't have these 2. These are not the component. We have 3 separate vectors, 5 Newton, 10 Newton and 1.34 Newton with an angle 30 to the 10 Newton. So this angle is 30, the other angle is 60. Now what I want you to use the resolving vector method, resolve 10 into pieces, 2 pieces, to the horizontal direction and the vertical direction, and get the resultant of all 3 vectors using the vector resolving method and special derivatives of parallelogram law. Okay, we are going to go for a 5 minutes break while doing this, and then we'll meet again in 5 minutes. Right, let's do the question then. Hope you had a quick short meal and now we are going to understand this. So I try to teach this. This is a method. So I like to take you through the thought process. So what is this, the thought bubble? Thought bubble is how you think of this. This is not what you are writing in exams. When you look at this 5, 10 and 1.34, you can see the only inclined one is 10 and I remove it. I remove this 10 Newton. Remove this 10 Newton out because I can easily deal with these two using p squared plus q squared square root. Right? I can easily deal with that. So what do? We take this one and I resolve this. I want to resolve this. So how do I resolve this? Take the horizontal component, right? Take the horizontal component. Here is the horizontal component. And we all know that r cos alpha, that is 10 cos 30, 10 cos 30. And the vertical component r sin alpha, r is 10 sin alpha. 10 sin alpha. So now, if we go back to the initial stage of this discussion, we had three vectors. 1, 2, 3. Now we remove this 1, 2, 3 and we resolve this to 4, 5, and when you resolve, we don't have this one, okay? So now how many vectors we have? We have only 4 vectors now. This is the fifth one become the third one, so this is out. Right, so that is out. So we have 3 vectors, actually 4 vectors. Now we use 2 like this one and this one to the same direction, this one and this one to the same direction. So we can remove them. Sorry. So we can take the horizontal vectors together and vertical vectors together. So vertical vectors 5, which was this? The first one. And this is that the last one we saw. And then we can have the second one and the third one we saw. And now we have 4 vectors. And since this second one and third one to the same direction, we add them. And the fifth one and the fourth one to the same direction, we add them. Right? So that's our plan. So sin 30 is 0.5 and we get the final answer as 10 Newton to upward direction. Right? And cos 30 is 0.866 and you multiply and add them together and you get 10 Newton again. So that is to the horizontal direction. Now how many vectors we have now? So I call this say OY and I call this OX. Now I have 2 vectors, 1 and 2. So we started with 3 vectors and we resolve it to 4 vectors. Now we have 2 vectors. When we have 2 vectors, we can easily use our theory, okay? What is it? R equals p squared plus q squared square root. And we get 10 and 10 there and get the answers, yes. Similarly, we can have tan alpha, so you know that q and p together. and we get that find tan alpha. So let me go through this one more time slowly. Then you can figure this out slowly, and I'll give you time to copy down as well. And first of all, you can copy down the thought process. So here it is. So resolving vector part, yes. And copy down this and come to the point slowly. So we can add them together, right? And we can add them together and get the final results like this. Final answer. Final answer can be taken like this. Okay, so here we got the answers for the resultant R. So that is kind of explanation of this full story, right? R is 14.14 and alpha is 45 degrees. So that is the end of the vector resolving method. So we come to the last theory topic. That is vector polygon theory. Vector polygon theory. So it is completely the extension of the triangular theory for more than two vectors. So we have like say 8 vectors here. We have 8 vectors here. So when we have 8 vectors, A, B, C, D, eight vectors A, B, C, D, E, F, G, H. So we take A first and draw here. And then what do? We take B to the same direction and draw there. In my case, I have copy and pasted C vertically up and draw C from there. So that is something like, the extension of triangular theory. AB plus BC equals AC, okay? And now what is the resultant of AB plus BC? AB plus BC is what? AC. So this is AC. So this is AC vector. And then what do? We take another color and explain that idea. AC plus CD, and you can say that it is what? AB, okay? So AC plus AD is AD. AC plus CD is AD. And now what do? Now it's a triangular theory, continuation of triangular theory. So we take AD plus DE, right, and take as what? AE. So when we have AD plus DE as AE, so yes, so this is AE. Okay. So likewise, I can go further. I don't want to continue the diagram, ruin the diagram, and AE plus EF is AF. AF plus FG is AG. AG plus GE is AH. AS plus SD is AI. So AI is the final answer. So you can see that here this is resultant is AI. Resultant is AI. So that's how the polygon theory will give us the reasons. Now polygon theory consists 2 components. One, the mathematical format of doing it, and geometrical format of doing it. Those are the 4 theories we have in advanced level. So we go to past paper discussion. We go to past paper discussion. This past paper discussion will give you the full understanding of vector, 4 theories of vectors, right? So let's take one by one. Which of the following diagrams, this is 1993, very old syllabus part, but same question. Which of the following diagrams correctly indicates the addition of 2 vectors 6 Newton and 8 Newton? They're talking about 6 Newton and 8 Newton, right? So you know that this direction should be nicely, nope, this is wrong directions. So here the directions, okay, kind of quite okay, because going to one side and going to the other side, okay. So the directions wise, this is quite okay. The directions wise 8 and 6, okay. Directions wise, these 2 okay. Directions wise, these 2 okay. Yeah. So directions wise, these 2 are not okay, because you have to go one after the other. So we can cancel the 4 answers first. Answer 5 out. Answer 1 out. Okay. So then what we consider that, the direction of the other two. Starting point to the end point, direction wise, this is right. Starting point to the end point, direction wise, this is right. Starting point to the end point, direction wise, it is not right because we want the other side. So fourth one is out by considering the direction. Now since these two vectors are perpendicular, we should take the resultant. How do you take the resultant? R squared equals P squared plus what? Q squared. So then what we can do is we can find R, okay, 6 squared plus 8 squared square root. So R equals 36 plus 64 square root. So that is 100 square root and that is 10 Newton. So that is how we deal with this. So then the final answer is very clearly the third one. Okay. You can copy down the details. So we are going through the questions step by step, and if you need the tutorial, so you can communicate in the WhatsApp group and collect the tutorial. Go to the next one. Question number 2. Which one of the following pairs contains two vectors, quantities and one scalar quantity? One vector quantity and one scalar quantity. Now we know that displacement is a vector, acceleration is a vector, power is a scalar, speed is a scalar, work is a scalar, potential energy is a scalar, force is a vector, kinetic energy is a scalar, momentum is a vector, velocity is a vector. So answer is the fourth one. This is 1994. Right. Which one of the following pairs, sets of forces never produce a zero resultant? So this is an interesting question, right? So 1994 question number, additional question from 1994. So now which one of the following is not creating a zero resultant? Now we can add this using like 3. 3 means we go to the polygon theory, what we learned at last. So the polygon theory says we have a vector AB and we have another vector BC, and if it is not producing a resultant, so this should connect to point A. Starting point and the end point are the same. Both starting point and the end point are the same. So it is coming back to the initial point. So this is not a resultant. So this is x plus y plus z. So x ending up at y, starting at that point B, B to C, that is y, and C to A, third vector is drawn and completing the triangle. then there is no resultant, because if there is a resultant, there must be a gap between starting point and the end point. So we used our O-level knowledge to draw a triangle completely. We must satisfy a requirement. What is that requirement? Addition of shortest two sides must be bigger than the longest side. So we are going to use this theory. We're going to use this theory. Addition of AB, BC, CD, and shortest two sides AB plus BC should be bigger than AC, Even equal situation is like this. So so this is, if I'm not mistaken, this is called a linear triangle or something. So yes, so our answers are like, okay, 5 plus 5 is greater than 5. 5 plus 5 is equal, that is also fine, so that is creating 0 resultant. 5 plus 10, the two smallest sides, giving us 15, that is bigger than 10. So never produce a resultant is which one? The fifth one. Similar question repeats in 1996. Which of the following groups of forces acting on a body cannot have a zero resultant force? So similar story, I have no regrets. Quickly go to the answer, fifth one. Go to the next one. Now this is interesting work. 1997 question. Right? 1997 question. Very interesting work. What is it? Now we have three scenarios. Force F shown in the figure. This is the one we are talking about. Right? This is the one we are talking about. Right? And that resultant, right, is given by 3 F1, F2, F1, F2 and F1, F2. We'll see which pair will give us this resultant, and we through the nice animation. So we take A, situation A, we take F1 and we draw F2 from the point where F1 is over, and then we connect or we contact the starting point and the end point. So you know that this is the starting point and this is the end point. We connect them and this is similar to F. Now we take F1 and we take F2, and from the point it is over, starting point to end point, we connect and it's almost same as this. So we take F2 here, sorry, F1 here, right? And from the point it is over, we draw F2. And starting point to the end point, yes, you can see all three similar to this. So the answer is fifth one. Go to the next one. And now this is a polygon theory work. This is a polygon theory work. And this is how you construct it, right? So this is how you construct it. I construct all these images separately. This is OB. And what I do here, I take this OB from one place to another, here to here. Why? Because OC plus OB, and I bring OA to the point where it is over, and now I have to draw this from here and DO from there, and I draw DO from there, yes. And now this is the starting point and this is the end point. So the resultant is most closer to 4. So there are like now 8 vectors. We properly draw them and I take one by one. You can see what I can do. I take F1 and I take F5 backward and I take F1 and F5 resultant in the orange color or yellow color. So then I draw like the next one F3 and minus F7 opposite. So I can get the resultant of F3 and F7 in yellow color again. So I have F8 and it is opposite to F4. So I can get the resultant. Now I have three vectors. Now I have to take F6 and F2. And the resultant, now I have like 4 vectors. Earlier I had 8. I reduced to 4. And now I have to add them in an order nicely now again. Yes. One after the other, one after the other. Okay. So now it is almost this one. So the direction is OB. Direction is OB. Second answer. So in this case, I have 6 vectors. So I take OA, OD opposite. And then I draw the other one OE. And I can draw OB. And I can draw OF. And I can draw OC. And now starting point to the end point. Again, the direction will be OF. Direction will be OF. The yellow color final answer is OF. So 2012, an object is under the influence of an external force F. The magnitude and the direction of F is shown in the graph. Which of the following combinations of 2 external forces, F1 and F2, must be added? Along X and Y directions to reverse the direction of the force F without altering the magnitude. Okay, so let's do this. So see how we do it. OF1. So I mark the resultant F. Now what I have done here, so OF is the combination of this horizontal green color horizontal vector and the green color vertical vector. So you can say 0 to 2, 2 to 4, that is the resultant. So now what I want is to get that to the opposite direction twice, because you want to reverse this. So if you want to reverse this, you have to reverse this twice. So this is 2. So I draw 4 here. And we have 4. We draw 8 downwards. And I have no space, but I do it nicely later. Wait. So now that is 8. So we draw this. 4 to the left, 8 to the bottom, downward. So resultant will be this one. So yes. So that is the resultant of those 2. So you have to change this. Now you understand the point. 2 Newton to the right, return to the negative x direction, that is 4 Newton. And 4 Newton vertically up must be 8 Newton vertically down. So the answer is the 4th one. Because they are expecting us to reverse the vector. Yeah, they are expecting us to reverse the vector. Right? Now the point here is like, we have a vector that is OF kind of a vector and we want to reverse it. First of all, you have to reverse the two components. So x component is 2 Newton, y component is 4 Newton. So you need to reverse 2 Newton to the other side, twice bigger, because you want something twice bigger to reverse it to the same value. I mean, if you get the 2 Newton to the opposite direction, so 2 Newton and 2 Newton to the opposite direction, it won't be reversed, it will be 0, because we have OF and opposite one, so that is 0. So you need the similar one to the opposite direction. So that's the whole plan here. So we reverse this. And one more time, yes. Fourth one, right? Okay. Now we have 2014, another question similar. If 3 coplanar forces 20 Newton, 40 root 2 Newton, 30 root 2 Newton acts on particles situated at origin O of a XY coordinate system, as shown in the figure, the vector that represents the force necessary to keep the particle stationary. Okay, so now in that case, it is not reversing, you want to keep it stationary. So you need to balance the system. So you have like 20 up, you need 20 down. You need 40 root 2, you need 40 root 2. You need 30 root 2, you need 30 root 2 opposite. So that is giving the equilibrium or rest. So no movement, because we are reducing the resultant to 0. So we have 3, we need to introduce another 3. Let's see how. Okay. We had 20 Newton. So we bring this 20 Newton to a place, and 40 Newton, and 30 Newton. So this is our resultant. So we need to reverse this resultant, not reversing the resultant. We are balancing the resultant by giving something opposite. So that is going towards OB. So this resultant is turning to the opposite direction if you introduce something along OB with that size. Right, the next one, 17. In the figure shown, F1, F2, F3 represent fixed vectors of 3 forces acting at a point O in the XY plane. F4 is the vector representing a rotating force. Easy. So rotating force is there other than these 3. So we have a rotating force. So this rotating force, 3 situations given. Look at this. Now F4 is what? Which one of the following best represent the direction of the resultant vector for 4? So initial one is theta equals 0. So we mark the theta equals 0 first. Okay. We go for theta equals 0. Now here, now you understand the 4 vectors first. These are the 4 vectors, and I like to call this vector 1, vector 2, vector 3, and this is when theta equals 0. So this is horizontally to the x direction. Okay, we draw it. This is F1, and this is F2, and this is F3, and now we have horizontal vector. So horizontal vector theta equals 0. Okay. So this length but horizontal. So the resultant starting point to the end point, this is the direction. So what is the most probable ones? 2, 3 and 5. Okay. So we go to second case, 90 degree. F1, this F2, F3 here. And now here this is upwards, right? So because 90 degree, this is upwards, F4. So upwards. So you can see that it is here upwards. So this is the end point. This is the starting point. Starting point to the end point. Okay. And now you can see 1, 2, 4. Okay. Now we already have the answer because this is out. This is the answer. This is out. This is out. This is out. But for justification purpose, we'll do the last one as well. So 180 is opposite direction. So F4 is to opposite. F4 turns completely to this side, right? So F1 here, take F2 here. We take F3 there. Now we turn this completely. It completely means like, okay, it is going from origin to this side. Okay. Now this is the starting point, this is the end point, and this is the direction of the resultant. So possibilities are second one and fourth one. Sorry, second one, fourth one and fifth one, but we already got the answer. For justification purpose, we did the last part as well. Right, okay. 2018, A, B, C, D, E are 5 coplanar forces. So we draw all of them quickly first and take them to the construction. I took A, I took C, I took E, I took D, and I took B. B last, huh? So let me label them, otherwise you may not understand. A, C, D, E, wait. A, C, E, D and B, okay? And connecting A. So the answer is right. So the resultant is closest resultant is the fourth one. Closest idea of the resultant is the fourth one. We have taken them scan, but you can see that there are slight inconsistencies, but obvious only one obvious answer. (2019) question. An object is moving in a circular path V as shown in the figure. The change in velocity of, as a mistype here, of the object when moving from A to B is, okay, A to B. It goes from A to B. So B is the final one. So we take that, A to B idea. So initial velocity is V initial is Final velocity is upward b. This is the final velocity. So here it is final, and this is the initial, right? So what I did was to add them, because to convert the negative sign to the positive sign, I added this rightward one to the leftward. I changed the direction and added. And you know that when the vectors are like this, so this is this one and this is this one, right? So when we have them like that, and we get the p squared plus q squared plus square root. So our values are simple, and tan alpha is 1 because v over v, that is q over p, and that is 45. So the final answer is the fourth one. So which one of the following pairs of the quantities consists of a vector and a scalar? Mass, scalar, velocity, vector. Power, scalar, speed, scalar. Work, scalar, distance, scalar. Force, vector, potential energy, scalar. Momentum, vector, torque, vector. 28 people who do not know the torque, and you're learning it in angular motion. Final answer is fourth one. The displacement of magnitude 9 and 6 can be added. Give a resultant displacement. We know that now 9 and 6. The minimum value of the resultant is 9 minus 6, that is, 3 meters. 3 meters. Right? This is the minimum resultant. Minimum resultant. Okay, maximum resultant. 9 plus 6. That is 15 meters. I always write Newton, mistakenly writing Newton. Right, meter. So our answer must be between 3 meters and 15, 3 meters and 15 meters. Right? Asking can be 2. Can be. So less than 3, less than 3. Yes, our answer more than 15, more than 15. So the only possibility is 4 Newton. And that's all. And we have done this. And remember YouTube Live. So this is coming this year. This is coming this year. For sure. So prepare for this. And 2028 people learn this. This is coming definitely for your term test as well. So we have completed nicely vector, triangular method, parallelogram method and its derivatives, polygon method, vector resolving method, and all past papers from 1990 to 2025 completely done more than 35 years. Okay, so we will see you again with another YouTube live to cover up whatever you have missed from vectors. Have a wonderful day ahead and see you soon.